So this video talks about the application of different statistical tests. But before I go through this table, I would like to just clarify the difference between data that are interval versus nominal. So interval defines those type of data that you can quantify the amount. Like for instance, blood pressure. You can say it's 100 millimeter mercury versus 120 or 180 or whatever. So you can give an interval to it. Or another example would be like blood sugar. What is the blood sugar? It's like 100 milligram per deciliter versus 200 milligram per deciliter, or 150. The other type of data that we have to deal with is nominal. So the answer is either yes or no. So it's black or white. For instance, what's the gender? It's male versus female. Or does the patient have cancer or does not have cancer? And that would be the type of nominal data. So the first three tests that I've listed here, odds ratio, relative risk, and chi-square, are all being used for nominal data. So there are two nominal data and no intervals involved. An example would be a 2x2 table that has disease on one axis and then the risk factor, let's say for instance smoking, on the other axis. So that the patient either has the disease or doesn't have the disease and is either exposed to a risk factor or no. And odds ratio is being used for the evaluation of case control study, which will look into the past, so it's actually a retrospective study. Relative risk is used for cohort, which we follow up on the patients in the future, and this is a prospective study. And then chi-square test is the one that is used for evaluation at the present, cross-sectional. So it's just one time point we are using. We do not follow up on the patients. Now for Pearson correlation, there is actually two intervals out there and no nominal. For instance, let's say we want to compare the difference between the relationship between weight and blood pressure. And so one axis would have the weight and the other axis would have the blood pressure, and find out how by increasing weight there would be increased blood pressure. And then there is a Pearson correlation, R value, which will tell you how strong is the correlation. So if the number is positive, the closer it is to 1, the more direct the relationship is. If it's 0, then it would be a straight line, and if it's negative, coming close to -1, it would be reversed, but it would go this way. Alright, and that would be for Pearson correlation. An example would be, for instance, comparing weight, the effect of weight to blood pressure. And finally, we have t-test and one-way ANOVA. So for these, we will have one interval and one nominal test. For instance, let's say if we want to check the blood pressure in different genders, like male versus female. And so t-test is used when we want to just compare two means to each other. So let's say blood pressure in males versus females. And for this one, we're using t-test because it's being tested in two groups. But what if there is more, 3 or more groups? For instance, let's say we want to test blood pressure in patients with Alzheimer, Huntington, and Parkinson disease. In this case, we will have to use one-way ANOVA, and it compares means in 3 or more groups.